Hi everyone, sorry I can't be with you today. I've been asked to go and do some stuff at Willerton, but even though you've got a cover lesson, I'm going to try and teach you from afar, which is a bit exciting. So for this to work, I need Tom and Jakob to stop talking at the back and to pay attention. I need Chloe to put her phone away. I need you all to pay attention because I'm going to try and teach you via video. So watch the video. It's about 20 minutes long, but there's stuff for you to do in the middle, and then you've got some questions to have a go at, which I'll take in and mark over half term. We will come back to this topic. It's quite a tough topic, but I thought you could handle it. If you can't do the questions after the video, then you can do the questions on rate of reaction in the textbook, which I've written down the pages that they're on and given them to the cover teacher. So watch the video, have a go at the questions, and then I'll see you after half term. Okay, so you've all got sticky aims. Hopefully you've stuck them into your book, so we'll just go through them before we start. So our aims today are firstly to understand what is meant by relative formula mass, to be able to calculate the relative formula mass of a given compound, so we'll learn how to do that. I'll show you how to do that before I ask you to do some, and to use balanced equations to predict the amount of product that we made based on the amount of reactant used, and we'll understand what I mean by that a bit later. I'm not expecting you to balance any equations today, although that will be needed by the time we get to our exam. So before we can start calculating relative formula mass, we have to understand what the relative formula mass actually means. And before we can do that, we need to look at the periodic table. So here's a picture of the periodic table that you get in your exam, and you can see there are lots of numbers on the periodic table. Now I'm not sure whether you've already been taught what the numbers mean, but you need to know what these numbers mean in order to calculate the relative formula mass. So you'll see that there are two numbers for every single element in the periodic table. The bottom number represents, so for helium 2, neon 10, fluorine 9, and you can see it goes up one by one as you go across the periodic table and up the periodic table. The bottom number represents the proton number. So all atoms are made up of three fundamental particles: the proton, the neutron, and the electron. It isn't actually until C4 that you learn more about those three particles, but for now, all you need to understand that is the bottom number tells you how many protons there are in an atom of any of those elements. The top number is what we're more interested in when we're talking about the relative formula mass. So what the top number tells you, so 4 for helium, 20 for neon, 19 for fluorine, 16 for oxygen, and so on. The top number tells you the relative mass of that atom. So all the atoms are weighed relative to each other. So hydrogen has a relative mass of 1. So the fact that carbon has a relative mass of 12 means that carbon is 12 times as heavy as hydrogen. So this top number is what we'll be working with today, and that represents the relative mass of an atom of the element in the periodic table. So here is part of the periodic table a bit closer up. Okay, so you can see these numbers a bit more clearly now. So you can see that boron has 5 protons in the atom, but as I said, we're more interested in this top number, so it has a relative mass of 11. Carbon has a relative mass of 12. Germanium down here has a relative mass of 73, and so on. So I've picked out a few elements from the periodic table, and we're going to use their relative masses to calculate the relative formula mass of a few different compounds. And then once I've shown you a few, you're going to have a go at a few yourself. So in order to work out the relative mass of these compounds, we need the formula. And the formula we're going to start with is carbon dioxide to CO2. So we're going to work out the relative formula mass of carbon dioxide. The first thing to understand is how many of each atom there is in the compound. So this formula tells you that there's 1 carbon, because there's no number after it, so there must be only one of them, and 2 oxygens. So the first thing we've got to work out is how much 1 carbon weighs. So if we look at our extracts from the periodic table and find carbon, and look at the top number, we can see that relatively it weighs 12. So 1 carbon equals 1 times 12, which equals 12. We've also got 2 oxygens, so 2 times O equals 2 times the relative mass of oxygen, which is 16, and that equals 32. So that means the relative mass of carbon dioxide altogether is going to equal 12 plus 32, which equals 44. So the relative mass of carbon dioxide is 44. So I'll show you another example. So this time we're going to do sulfuric acid, so H2SO4. And this time, again, you're going to work out how many of each atom there is in the compound. So there's 2 H's, there's going to be 1 S, and 4 O's. So we're going to work out what 2 H's weigh. So 2 times H has a relative mass of 2 times 1, because hydrogen has a relative mass of 1, looking at its symbol, which equals 2. There's also 1 sulfur, which will equal 1 times 32, because if we look at the periodic table again, sulfur has a relative mass of 32, which equals 32. And we also have 4 oxygens, so that will be 4 times 16, which equals, because 16, because oxygen has a relative mass of 16, which equals 64. So if we add all those together, what we'll get is 2 plus 32 plus 64, which equals 98. And so my relative mass of my sulfuric acid is 98. So if I show you one more before I ask you to do some yourself, this one is a little bit more complicated because it has brackets in it. So it's going to be NH4, 2 of them, SO4. Okay? And what this 2 represents is that there's 2 of everything in this bracket. So what I would do first is work out what NH4 weighs, and then times it by 2, because there are 2 NH4s in this whole formula. So first I'm going to work out what N weighs, so N is 14, 4 H's is going to equal 1 times 4, which equals 4, so NH4 weighs 14 plus 4, which is 18. So in this formula, I have 2 NH4s, because remember the bracket, the number outside the bracket represents how many of everything there is inside the bracket. So that's going to equal 2 times 18, which equals 36. There's also 1 S, which equals 1 times 32, which equals 32. And there are 4 oxygens, which equals 4 times 16, because 16 is the relative mass of oxygen from the periodic table, which equals 64. And if we add all those 3 things together, what we'll get is 132. So 132 is the relative mass of NH4 to SO4, which name is ammonium sulfate. So, now I want you to have a go at some, so I'm going to ask you to try and work out the relative mass of SO2, sulfur dioxide, relative mass of calcium carbonate, CaCO3, the relative mass of lead nitrate, and the relative mass of aluminium oxide. You have the time it takes for Crystallize by the XX to play, and that song is 3 minutes 22 seconds long. So after that, I'm going to give you the answers. Don't worry if you don't get them all done. But that's the length of time you have in order to answer them.
Tell me crystalline, and you've got the faith that I could bring paradise.
I'll forgive and forget before I'm paralyzed. Do I have to keep up the pace to keep you satisfied?
Things have gotten closer to the sun, and I've done things in small doses. So don't think that I'm pushing you away when you're the one that I've kept closest.
You don't move slow and taking steps in my direction. The sounds echo. Does it lessen your affection? No.
You say I'm foolish for pushing this aside, but no, I won't leave without.
Glassy as a mountain to the sea. I wish the tide would take me over. I've been down on my knees,
And you just keep on getting closer. Getting closer to the sun, and I've done things in small doses. So don't think that I'm pushing you away when you're the one that I've kept closest. Go slow, go slow, whoa. Go slow, go slow, whoa. Go slow.
So, how did you get on? I'm just going to quickly run through the answers to see if you got it right. So, sulfur dioxide, we'll do that one first in red. So, sulfur, there's only one of those, and that weighs 32. There are 2 oxygens, and there's 2 of those, so that we're going to add 2 times 16, because oxygen weighs 16, so that equals 32 plus 32, which equals 64. So, sulfur dioxide is 64. I'll do the next one in blue. So we've got calcium, which weighs 40. We've got 1 of those. We've got 1 carbon, which weighs 12. And we've got 3 oxygens, which each weigh 16. So if we add all those together, we should get 100 exactly. The next one I'll do in purple. So lead nitrate, we've got lead, which weighs 207, and then we've got 2 lots of NO3. So we've got 2 times 14 plus 3 lots of 16, which equals 48. So 14 for the N and 48 for the 3 lots of oxygen. So 2 times 14 plus 48. And so this all equals 331, if I'm not mistaken. And then I'll do the last one in brown. So here we have 2 aluminiums, and each of those weighs 27. So 2 times 27 plus 3 times 16 for the oxygen, and that equals 102. Okay, so let's move on. So now we're going to move on to our last aim, which is using equations to predict the amount of products that could be made if you know the mass of the reactant that you're using. Now to put this into a little bit of context, the first thing I want to do is just show you the reaction of magnesium with oxygen, which I'm sure you've seen many of times before, but you're going to watch a video of that anyway. So here it is. So during that video, you're watching magnesium burning, and basically when magnesium burns, it's reacting with oxygen. So we can write a word equation for that. So it's Mg, sorry, not a word equation, a symbol equation. So that's Mg plus oxygen, which is O2. Oxygen gas is oxygen ground in pairs. It's not just O, it's O2, and that makes a white powder, if you're looking carefully in the video, which is magnesium oxide, MgO, just one O this time. Before we can move on, we've got to balance this equation. So 2 magnesiums will react with 1 oxygen molecule to make 2 magnesium oxides. Now, as I said, I won't expect you to balance anything in today's lesson, but I will expect you to be able to use these equations in order to calculate answers. So the first thing we've got to do is think about how much magnesium will react to make a certain amount of magnesium oxide. So to do that, we need to work out their relative masses, but not just the relative mass of 1 magnesium, the relative mass of 2 magnesiums, because 2 magnesiums reacts to make 2 magnesium oxides. So 1 magnesium, if we look at the elements up here, weighs 24, so 2 of them will weigh 48. 2 magnesium oxides will weigh 2 times 24 plus 16, and that equals 24 plus 16 is 40, so that equals 80. What this tells us is that if I have 48 grams of magnesium, that will burn in a plentiful supply of oxygen to make 80 grams of magnesium oxide. So, using this, I can say that if I had 24 grams of magnesium, which is half 48, that would make 40 grams of magnesium oxide, because that is half. Everything, this is just ratios, this is just using ratios. If I use half amount of magnesium, I'm going to make half amount of magnesium oxide. But to work out how much magnesium oxide I would make from a certain amount of magnesium, the first thing I've got to do is work out the relative masses. Similarly, if I use 12 grams of magnesium, I would make 20 grams magnesium oxide. If I use double the amount of magnesium, so say I use 96 grams of magnesium, that would react to make 160 grams of magnesium oxide, and so on. So next thing, I'm just going to show you another example before you have a go at some yourself, and that example is going to be the decomposition of calcium carbonate. So that's CaCO3, heated, makes CaO plus carbon dioxide. So, the first thing we've got to do is just work out the relative formula masses of calcium carbonate and calcium oxide, because that's what my question is going to be related to. So calcium carbonate will weigh 40 for calcium, plus 12, plus 3 times 16, which is 48, and that equals 100. And then calcium oxide will be 40 for calcium plus 16 for oxygen, which equals 56. Now, if I ask the question, how much calcium oxide could I make, and this is calcium oxide on this side, could I make from 40 grams of calcium oxide, sorry, calcium carbonate, so I'm using 40 grams of calcium carbonate, and I want to know how much calcium oxide I can make from that much. The first thing I've got to do is work out what I have to do to 100 to get to 40, if you like. If my number here was 50, it'd be very easy. I'd know that all I had to do was divide by 2 here, which means I just divide by 2 here to work out how much calcium oxide I'd make. But it's not quite as straightforward as that. So the first thing I've got to do is work out what number I've got to divide by to get from 100 to 40. And that's going to be the same number that I divide by on this side to work out how much calcium oxide I would make. So to do that, I need to do 100 divided by 40, and that equals 2.5. So I know that to get from 100 to 40, I need to divide by 2.5. So to work out how much calcium oxide I would make, I divide 56 by 2.5, which equals 22.4. So I know that if I used 40 grams of calcium carbonate, I would make 22.4 grams of calcium oxide. So before you have a go at a few yourself, I'm just going to recap the steps you have to take in order to work out the amount of product you'd make if you knew the amount of reactant you're starting with. So first step is you calculate the relative mass, or relative formula mass, sorry, of the relevant compounds. Then second, multiply this. So multiply this by the big number in the equation. So if you just look to the top of the screen, I'll show you what I mean by that. So in the magnesium oxide one, we had magnesium plus oxygen going to make magnesium oxide, and we balanced it with 2 magnesium and 2 magnesium oxides. So the big number, I mean, is this 2. So once you've worked out the relative formula mass of, say, the magnesium oxide, you would multiply that then by 2 to give you your ratio of magnesium to magnesium oxide, if you like. And the last step is you calculate what you have to divide by to get from formula mass to the mass you are using. So that's a bit rubbish. So let's go through these once more. So number 1, first you calculate the relative formula mass of the relevant compound. So in this case, first, if you were trying to work out how much magnesium oxide you were making and you knew how much magnesium you had, you just work out how much the formula mass of magnesium, which would be 24, and the formula mass of magnesium oxide, which would be 24 plus 16, which is 40. Then you multiply those by the big numbers, which I mean here and here. So you multiply 24 by 2, which will give you 48, and you multiply this 40 by 2, which give you 80. And then you would calculate what you had to divide by to get from the formula mass to the mass you were actually using. So, say I'd done all this, so I'd worked out that 48 grams magnesium gives 80 grams magnesium oxide, but actually I was using 24 grams of magnesium. I know that I have to divide that by 2. So I divide 80 by 2 in order to work out how much magnesium oxide I would make. So now what I like to do is have a go at the questions that are handed out to you. You can also use a textbook to help you, because obviously this video is not on the screen anymore, and your revision guides to help you as well. What I'll do then is ask for that to be collected in, and I'll mark it over half term and see how I've got on. We're not going to go on from this until you understand it. It's quite a difficult concept, but I thought I'd try this out to see if it worked. So good luck, and have a good half term, and I'll see you first Friday back.